Okay, let's solve the first question. चलो सॉल्व करो पहले क्वेश्चन को. प्लीज सॉल्व द फर्स्ट क्वेश्चन. Only 13 questions here, 13, 14 questions, 13 questions, I guess. That's it. This will revise all the concepts there in this unit. So Govind का 250 आया, 250 Weber. Sudama का 250 आया, Weber. Okay. So 2 students are giving the answer for this question. Anyone else? आप try करो जल्दी से आंसर दो इसका. अंजलि का 2 है, yes. निधि का भी 2 है, 4 लोगों का आ चुका आंसर अभी तक. You can say easy question है, it's easy question. In a coil of resistance 100 ohm, a current is induced by changing the magnetic flux through it as shown in the figure. The magnitude of change in flux through the coil is. This is the question. Okay, let's see solution for this question now. It's a very, very easy question. Please hear. See what is given to you first. You make a note of all the given things. What is given here? You can see that resistance is given as what? 100 ohm. 100 ohm. The current is induced by changing the magnetic flux through it as shown in the figure. So actually changing the current. The current will produce magnetic field and hence the magnetic flux will also change. They're asking you what is the flux change. Delta phi is the flux change. Delta phi b magnetic flux equals to what? This is the question. Okay, so now we know that EMF induced. What is the formula for that? EMF induced is always minus of d phi by dt. This is the value. So what is current? Current will be equals to EMF by resistance. This is the formula. So we'll get here what? Minus of 1 by R d phi by dt. Now this is a very, very important. So 3 important results you have. In fact, you should multiply with n also if you have n number of terms. This first equation that you have. Very, very important for this chapter. First equation. Second that you have is this equation. Very, very important equation. One more equation we have is very, very important. See, you can write I equals to what? dq by dt. dq by dt. What is that? That is basically 1 by r d phi by dt. So you can cancel dt dt. So you will get dq equals to what? dq you will get as what? Minus of d phi by r. So these 3 equations are very, very important. First of all, take the screenshot of this. Screenshot ले लो सबको पहले. See, we know this ना. EMF induced in a closed loop is given as what? Number of turns multiplied minus of n d phi by dt. And what is I? I is E by R. So E by R when you do, you will get this. Obviously, if you have n, you will multiply with n also. What is I? dq by dt. So dt can be cancelled. The charge flown in the loop will be this. Right? This is what you have. These 3 questions. Now for this particular question, so whenever you solve any question of EMI at a basic level, definitely you will be using either this or this or this. That depends upon data and what is asked in the question. Like here they're asking you delta phi b. Delta phi b. Delta phi is available here, here, as well as here. So which equation will you use? But they have given you current. Current is available only here. So for solving this question, we have to make use of this equation. So will you make now? We'll take this equation. I equals to what? I equals to, we'll write here minus of 1 by r d phi by dt. So we are asked to calculate total flux change. So what we'll get from it? We'll get d phi equals to what? If we take only the mod, let's say I'll take the mod of this. So we'll get here I in r into I into dt. We'll get like this. So from here we will get now. This is what you have. So what is total flux? 5 will equals what? Integration of R into I dt. So this is what, this is nothing but the area. This is nothing but the area that you have here. This is basically the area. This total, this is so R into area of IT graph area. Target. What is R given the question? R is given as 100 into a triangle, right? So half into base. What is base here? Base is your 0.5. 0.5 is half into height. What is height here? 10. So let's solve this. This will give what? 5. This will give what? This will give 50. So what is the answer? 250 Weber is the answer for the question. A very, very easy question. If anyone is having doubt in this, please ask here. किसी को डाउट है इसमें प्लीज पूछ लो. Yes, you can take the screenshot. Okay. So again, I'll repeat in case if you're not asking again, I will only repeat from my end. See, according to Faraday's law, what do you know? EMF induced in a closed conducting loop through which you have area of flux, right, is given as E equals to minus of d phi. This is for a single loop. What is d phi here? Change in flux linked with the loop there. And if you multiply with n, for n loops, you will get the EMF induced. And what is the current value in that same loop? If I ask you what is the current induced, you will write I equals to E by R. So you can write from it. So you'll get this. But what is I? dq by dt. Dt you can cancel. So change the charge that has flown through the loop is given this formula. Now coming to this question, what they're asking the magnitude of. They have asked you the magnitude of the change in flux through the coil. D phi is available here, here, here. But they have given a current time graph. So why the flux is changing with the loop? Because the current is variable here, right? So we will use this equation. So what is I? I is this. So we'll write it here. So we want d phi. We'll cross multiply. So what is phi? Integration. Integration is about the area here. So just take the area from here, and we'll get the answer for the question. किसी को doubt है please पूछ लो यार. If anyone is having doubt in this question. Okay. So you can never say that this is a question where the concept you are using from some other planets, let's say Pluto or Jupiter, it's very much given in NCR textbook. The only thing you are not seeing the concepts like this. It's so easy. Unnecessarily, you keep making what you call notes every day, feeling that you are doing a great job. You are doing some what you call miracle in this world. No, ऐसा कुछ नहीं कर रहे हो. You are doing a very, very what you call horrible thing if you are doing that. Yeah, you are making notes. You are making what you call teachers happy to get 2-3 marks. बहुत ही घटिया काम कर रहे हो. Please see like this. The entire physics should start seeing like this. Yeah. It's actually easy. Okay, let's see the next question now. Please solve this question. Yeah, please solve this question. So there's a small mistake here in the question. Yeah, there was point given everywhere. So point was missing. So I'll put point here. 2.1, 0.6. Like this, you have the answer. This point 0.14, 0.7 millicoulomb, 2.1 millicoulomb, 0.6 millicoulomb. This is what you have the question. Please solve it. A conducting circular loop made of a thin wire has area 3.5 10 to the power minus 3 meters square and resistance 10 ohm. It is placed perpendicular to the time dependent magnetic field. This is what the magnetic field you have here. It's variable, you can see here. The field is uniform in space. Okay. Then the net change in the net charge flown through the loop during t equals 0 to t equals to 10 millisecond is close to. This is the question. A very, very easy question here. तो ये बताओ इसका आंसर यार, सब तो लिखा हुआ है इधर, कैसे सॉल्व करना है, अब क्या है इस क्वेश्चन में? There's nothing in this question. अरे conducting circular loop made of a thin wire has area 3.5. If you're not solving, then I will solve the question for all of you. It's a very, very easy question. चलो मैं ही सॉल्व कर देता हूँ यार, इसने आंसर दिया लगता है 0.14 मिली कूलम, एक आंसर आया है 0.1। चलो कोई और देखो आंसर दो। पॉइंट ये ऑप्शन नंबर ये है, एक और आंसर है, निधि का वन है। यू ऑल ट्राई, इसे क्वेश्चन है, इट्स एक्चुअली इजी क्वेश्चन। चलो मैं ही सॉल्व करता हूँ, देयर इज नो पॉइंट इन वेस्टिंग टाइम नाउ हियर, सो आई विल ओनली सॉल्व द क्वेश्चन फॉर ऑल ऑफ यू। सी व्हाट इज गिवन टू यू हियर, a conducting circular loop made up of thin wire. Okay, so you have a circular loop here, has area of this loop is given to you. What is the area value is given as 3.5 10 to the power of minus 3 meters square, and resistance 10 ohm. Okay, so resistance of this is also given as what? R is given as 10 ohm. It is placed perpendicular to the time dependent magnetic field. Okay, so the magnetic field is perpendicular. This information is given in the question. This magnetic field is what? Perpendicular to it. And what is the value of B? B value is also given to you as, the magnetic field is given as 0.4, obviously Tesla, sine of 50 pi t. This is what you have. Magnetic field is given to you. The field is uniform. They're asking what is the charge, net charge flown through it. Okay, you can see that as time changes, what will happen? Flux linked with this will change because the magnetic field is variable here. By the, what is the flux at any instant? We will use the formula B into area into cos of angle between them. Since both are in the same direction, you can just write BA. So area is given. They're asking delta. So charge flown is given by what? Change in flux divided by resistance. Resistance is also given in the question, 10 ohm. Just calculate the change in flux. What delta phi then? Final flux minus of initial flux you will do. That's it. So we'll get here. A is constant. So B final minus of B initial. That's it. So area is like 3.5. Okay, I will keep it as A only. What is B final? In place of T, you put what? You put 10 milliseconds and then initial T goes 0 seconds. So put here. So we'll get 0.4. I can take 0.4 also outside if you want. You can take 0.4 also outside. What is remaining here? Sine of 50 into pi. What is time here? In the time, final time, 10 millisecond. 10 milli means what? 10 by 1000 milli. Minus what? Time goes 0 means sine 0. Initially 0. So 0 only. We'll get from it. What 2 zeros you can cancel from is 2. So pi by 2. So half. We will get what? A into 0.4 by half. What is the formula for delta Q? Delta Q will be equals to what? What is the flux you have got? What is the area value? Area is given as 3.5 into 10 to the power minus 3 into what? 0.4 by 2 you have, and then you divide by the resistance. That is 10. So now you have to solve this, right? So after solving this, we'll get from here. See, 0.4 I can cancel. I can write a 2 by 10. I can write 2 by 10 here, right? 2 by 10 here. And then if you multiply these two, I'll get here. This is 7, right? 7 I'm getting here. कुछ गलत हो गया क्या कहीं पे? 3.5 10 to the minus 3 is correct. It's given. Into 0.4, correct. Into half. Oh, sine pi by 2 is 1. No, sorry, sine pi by 2 is 1. This is not half. You will not get half here, sorry. Because this is 1, no, this is 1. Sine pi by 2 is half. So there is no half here. We'll have just 0.4 here. Okay. You'll have just 0.4 here. So this will be just 0.4. So when you multiply these two, you will, this is micro. This is micro only. Okay. And now you have to just solve these values. 3.5 multiplied by 4 by 100. You have to solve this. You'll get micro coulomb. Okay. So 3.4. So we'll get 0.14 millicoulomb. So we'll get 0.14 1 millicoulomb. This is the answer to the question. You can see a very, very easy question here. If you want, you can take the screenshot now. You can see the questions are so basic here. The questions are really basic. You can see here. If anyone is having doubt in this question, please ask here. So the first two questions, what I have taken here is to explain you the basic Faraday's law of electromagnetic induction. So you can write in your notebook now that Faraday's law of electromagnetic induction is over now. So we have revised. And these three questions you should always keep in mind for your board or competition anywhere. I'm just revising the entire topic. This is the first set of equations that you have. This is a Faraday's law. So Faraday's law I have covered for all of you. Please make a note of these three formulas. I discussed the questions also based on these formulas here to give you a clear picture how to use it. Right? They were actually easier. Let's see the next one. Now this question, this or this. These three questions I have taken on the next topic, that is your motional EMF. Okay. You know the formula of motional EMF. I'll just quickly review it and then you can start, or if you want, you can solve it. Yeah. You can start solving. Solve this question. They're actually easy. Yeah. There's nothing in these questions. Please solve it. The next three questions what we are going to discuss here are based on motional EMF. Okay, so you may find it very difficult. Okay, so first I'll review the concepts in motional EMF. Please see it. It's an answer दिया side. So Anjali is giving the answer as 1. Okay. का answer बना रहा है. Okay, I'll just discuss the concept with all of you first. So after that, you can see the questions are actually easier. See, the idea is very simple. That through this series, I'm trying to prove you that what you study in NCRT, almost same thing you have in what you call Neet and JEE. It's not different. The only problem is you're not keeping your what you call islands clear that it's actually the same. The school teacher, again I'll come to the school teachers only. The school teachers and your name, what you call school curriculum, makes the image very blur in front of you. It's not a very difficult thing. You won't be able to do it, and then actually you won't be able to do it because in English it's a very famous saying here: thought becomes thing. They deteriorate your thought to such a level that you never feel like you can crack the competitive exams. You can go to a good college, and then actually you don't go to a good college. You go to Acharya, Nitte, Fitte, all those colleges you will go. So please, it's a time. Please wake up and try understanding that whatever you're studying is up to the mark, and definitely you will qualify. Don't be overconfident, by the way, but yeah, you should have confidence. Okay, so one answer is coming as Shruti is giving answers 3. Okay, so 2 options we have got. Okay, I'll just review the concept first and then we will see the solutions here. Please see. If you remember, this is what we had discussed with all of you. Only 2 concepts we have seen in motional EMF that is given in NCERT textbook. Yeah. Both highlighted here. Let's say you have an uniform into magnetic field. Let's say you have an uniform into magnetic field. Okay, so now let's say you have a rod here. You have a rod here. The length of this rod is given as what? L. The length of this rod is given as what? L. This magnetic field is B, is going into. And then we have seen that if we move this rod with a velocity V, so we can do V cross B now. So V cross with your thumb will come this side, but due to negative charge, I have discussed all these concepts. What will happen? This end will become what? Negative. Here you will get negative, and this end will become positive. This end will become positive, and then you will get a motional EMF, right? And the electric field that is developed here, E, and then you will get a voltage difference, right? I'll straight away write the voltage difference and not write the E value, not required also. Straight away I write the voltage now. The voltage developed here V. This is let's say italics V. So this is a voltage difference V. So we got V equals to what? VBL. We got this V equals to VBL. We got the value of this V, capital V as what? VBL. This is what we have studied, right? ये देखा है. Now I'll just tell you a very, very important thing today here. That is, always remember this diagram. Let's say x-axis, let's say y-axis, and let's say this is your z-axis. So in this case, we have one is your velocity, one is your length. So I will write like, see, let's say on one axis I will write length, and on one axis I will write what? V. On one axis I will write what? I will write here B. So this is. So what is the meaning in this? When you write this formula is valid only when your velocity, length, and magnetic field are mutually perpendicular. This is a very, very strong concept. Normally, you will not find the same written in the school books, but this is what you have. If you see with a clear understanding, you will find that yes, this holds true. Then only this result is valid. That is your potential difference is VBA. This is the first concept. Velocity, length, and magnetic field are always mutually perpendicular. Then only you will write this result VBA. First concept. Second, if you recall, we have seen one more concept, that is, if you take a magnetic field and this time you start rotating a rod with an angular velocity omega. Let's say you take a rod here now. You take a rod here. Let's say the length of the rod is L. You have fixed it. You have hinged this or pivoted at this end, and you start rotating this with an angular velocity omega. So we have seen the concept. We have derived the formula also. Derivation is very, very important. It is given in NCERT solved example. You take any what you call at any x, you take a small element here dx. It will form a circle. It will perform a circular motion here. So what is the v for it? The v for it will be your, now omega, v equals to omega. So you will get omega into x. So what is dv value? dv will be your vb. This vbl we can apply here. So v is what? Omega x into b into dx. So what is the total potential difference you will get? B into omega will come outside. X dx you will get integration from where to where? 0 to L. So we will get B omega L square by 2. This is the formula for potential difference. This is how we get. But then how you get the polarity? I discussed with all of you. If you calculate here, what you have? Here you have basically an electron. What is the force on electron? You write force on electron will be your minus of E V vector cross V vector. So when you calculate V cross B, your thumb will point is set, but since negative, so this end will become negative here, and this end will become positive. So this much concept we have in motional linear graph. Okay, if you want, you can take this screenshot. Now see the questions. If you want, you can take the screenshot. If anyone is having doubt in these concepts, you can ask her. I've just explained the same thing what is given in NCERT textbook. I've discussed everything in detail with all of you. In case if you have not revised, I have revised for you now. So now let's solve this question here. See what is given to you. This is the point. This is with respect to this point, this rod is rotating, right? And the length from here to here is given as what? 12. This is given as what? L. Same thing you can use here. Same thing. This is omega. It's given to be omega. The only thing, the limit that you have put here, it will vary from 12 to 3L. This will 12. This will be what? 3L. That's it. Everything else is exactly the same. So what is the EMF value we'll get? V equals to, we'll get here. We'll get B omega. This integration x dx only will get same thing, but only the limit of integration will change from where to where? From 12 to 3L. Everything else is same. So what will get? You will get B omega x square by 2. From where to where? 2L to 3L. That's it. So b omega by 2 will be outside. 3L square will get 9L square minus of 2L square. So we'll get total 5L square. So what we'll get here? So b 5b omega L square by 2. That's it. Question is over. How you can say that it's not a question from NCR textbook here? Impossible. You can't say that. If you want, you can take the screenshot. If you want, you can take the screenshot. If anyone is having doubt in this, please ask. You can see it's a very, very simple question straight away from your textbook. Please take the screenshot fast here. I will remove this now. This is what we have used here. This is the same derivation what you have done in NCR textbook. We are changing only the limit of integration. Because in this case, x varies from 0 to L. But here x will vary from, in this rod now, you are getting the EMF induced. It varies from where to where? 2L to 3L. So write 2L to 3L. And then let's put the limit. We'll get the answer for the question. Everything is the same. They have not asked the polarity, right? They can always ask the polarity also, but they have not asked it in the question. They can write here with A and B, this end is a high potential, lower potential. They can write. They have not asked it here. So you can just remember that. What happened? This end will be your negative, lower potential, and this end will be your higher potential. This is not asked here, but in some question they can definitely ask you this also. Which end is at higher potential, which end is at lower potential. Okay, so let's solve this question. Again, a very good question, not difficult. It's not a difficult question, but a good question. Yeah, अच्छा question. The only problem, like I have to. Okay, no issues. To rub these things. I'll just remove these things now. Solve this question. A good question, a very good question. Trust me. Not difficult. Good question. One line answer. But for that, you have to understand everything. Please solve this question. A solid metal cube of edge length 2 centimeter is moving in positive y direction at a constant speed of, it's speed here, it's a misprint here. It's a speed, constant speed of 6 meter per second. This is uniform magnetic field. There's a uniform magnetic field of 0.1 Tesla in the positive z direction. The potential difference at the two faces of the cube perpendicular to the x-axis is the question. Please solve it. A very good question, yeah, to clear all your concepts regarding this what you call motional EMF in a straight line, in a straight rod. It's a solid metal cube. It's very important to note this. It's a solid metal cube. किसी का आंसर आ रहा है? Easy question. Think. Difficult, but it's not difficult. 12. 12 millivolt. It's actually easy question here. Okay. 12. Okay, so I'll give the solution now. Let's try to understand this in detail here. Okay. Many of you have given the answer as 12. Okay, so let's see the solution now. How you get 12 here? Okay, this is what I'll explain you now. Please hear. If anyone wants to give an explanation like how you got 12, you can write in the chat box here. I'll just see. किसी कुछ explanation लिखना है how you're getting 12 in this question, you can always answer it. If anyone wants to answer it, like what is the logic with which you have got 12? If you want to write, you can write in the chat box, sir. Is anyone writing here? Okay. Others can try. It's actually easy question here. One line answer. It is one line answer. You don't need to use more than one line to get the answer for this question. VB. It's not VB. It's VBL. Yes, VBL you have to use. Correct. Okay, let's see here now. Okay, no issues. I'll explain now. See here. First of all, I told you that for motional EMF, what is the requirement? Requirement is velocity. First requirement is velocity. Second requirement is magnetic field. And third requirement is your length. And it should be important that all three should be mutually perpendicular. All three should be mutually perpendicular. This is what you have now. Now, see here. You can straight away remove which all faces. See here. This face, y-axis is parallel to 6. So this side you will not, along the y-axis you will not get any EMF induced. As simple as this. See, you can divide the entire cube into what? Into rods like this. These rods are parallel to y-axis, but this, if you take this y-axis, no, none of the rod will have any EMF. The reason is this: they're not mutually perpendicular. V is parallel to B. V is parallel to this this length. For why will not get EMF? Because in this case, length is parallel to what? Length is parallel to V vector, and hence will not get anything like here. Similarly, if you take anything on this side, that is your this plane. What is this plane here? In the back, let's say this plane, this particular plane. So not this plane. One more plane. Like this, you have one plane. Let's say if I take anything on this plane, let's say this plane, that is your XZ plane, and you can create rods like this. No? You can create rods like this. Now this will also not have any, because the magnetic field is on z-axis. No? So in this case, length will become parallel to B vector. So on this also you will not get any EMF induced. So in two dimensions, on two what you call different dimensions, the magnetic field cannot be induced, cannot get induced. Now if you see the rods cut like this, that is parallel to x-axis. So parallel to x-axis, what is the benefit? Your velocity is perpendicular to x-axis, and your magnetic field is also perpendicular to x-axis. So all the rods cut like this. So you can divide the entire cube. You can take the entire cube. You can take the entire cube. This is the cube that you have. You can start cutting the cube into small rods like this. This is your x-axis. This is your x-axis. So what you can do, you can start cutting the rod like the thing like this. See, let's start cutting like this. This is one sheet of rod, and again second sheet like this. You can fill the entire thing with rods like this, and in all these rods you will get EMF induced. But when you're calculating EMF here and here, you can see that all these EMFs will be in parallel. Because this side, whatever the potential you have, let's say V1, here your potential is V2. What will happen? For all the rods, V1 minus V2 will be same. So all will have same potential. So you know that whenever you have n number of EMFs connected in parallel, the equivalent EMF is always equal to only one EMF. So I'll take only one rod now, only one rod, that's it. And what is the length of this rod? The length of this rod is given as what? 2 centimeter. 2 into 10 to the power of minus 2 meter. Is what? 2 by 100 meter. V, this is your L. So what is V? V is your 6. So VBL, 6V into B. What is B here? B is given as 0.1 Tesla. So 1 by 10 into what? 2 by 100 you will write it. So we'll get what? 12 millivolt is the answer for the question. That's it. Question is over. Such a beautiful question here. It clears the concept of motional EMF so nicely. You want, you can take the screenshot here. Always remember that only over such lengths you will get EMF induced where this condition is satisfied. What is the condition here? your V, that is the velocity of the rod, the magnetic field, and the length of the rod. All three are mutually perpendicular. Only over such lengths your EMF will get induced. But what happens if you have multiple EMFs induced and all are parallel? Same EMF induced parallel. So you know that if you have multiple EMFs, right, what will happen? And they are parallel. The equivalent EMF will be equal to what? EMF of a single. And trust me, this is given in NCRT. See, I will show you. I've told you today also I'm not crossing the NCRT level. If you feel like it's very difficult concept, I'll show you. See here. EMI NCRT book. Same question is given. Similar question. I'm not saying same question, but similar question I'll show you in NCRT. In solved example. I'll show you in solved example. See this question. Question number on this question. 6.7. Exactly same thing here. A wheel with 10 metallic spokes. Exactly same question. Not same, but then the scenario is same. You have a wheel here and you have 10 spokes like this. So obviously you can see the EMF induced. All these are what? Parallel, no? Because one point is here and one point is on the wheel. So what will happen? You'll get EMF induced in all the rods, but all the rods are what? Parallel. So what will happen? Equivalent EMF will be EMF in only one rod. It's given in NCRT textbook. See here, the same explanation is written here. So you can't say that I'm solving something from Pluto or Jupiter. This is given in NCRT. See here, solved example. You can't say that I am crossing the level of NCRT. No, I'm not crossing this level of NCRT. Nor my intention is to cross NCRT level. Even in JEE and Neet will never cross NCRT level. Even in JEE, 50% question, 60% question will be from NCRT. If you don't believe me, go and watch the toppers video. You'll get to know that. This all depends upon how you take these things here, take this guidance. Same concept is given in NCRT solved examples here. That's why I have very clearly written here. Hence, basic numericals. The heading of the PDFs is I have given the clear heading NCRT level. Basic numericals NCRT level. Okay. Still, if anyone is having doubt here, please ask here. So in this case, if you divide the entire solid into what? Parallel lines like this, and these parallel lines are what? Along the x-axis. So in all the lines, you will get an EMF induced. But all the lines with reference to these two, what we call these two ends. By the way, they have asked also the same thing. By the way, we know that it will not occur for other ends. I explained you, though it's not required in the question, but I explained in detail. It will get into, and why they all are in parallel. You can see from it. And so whenever you have multiple EMFs, same EMF connected in parallel, the equivalent is always equals to the EMF of a single rod. A single rod is VBL. Question is over. That's it. And why each rod will satisfy this condition? And therefore, yes, it's correct. Over. Question is over. Okay, let's see the next question. And do solve these questions. I request all of you. You will top in boards. You will definitely qualify in Neet with a very good rank if you're solving these questions. In JEE also, 60 to 70% weightage of questions will be like this only. You can solve it very easily. In CT Comet, again, you will top rank 1 if you're solving this question with this much clarity here. Don't try to buy heart here. Please solve this question. Last question for most anyway. A 10-meter long horizontal wire extends from northeast to southwest direction. Okay, it is falling with a speed of 5 meter per second at right angles to the horizontal component of the Earth's magnetic field, that is 0.3 10 to the power minus 4 Weber per meter square. The value of the induced EMF in the wire is a very good question. I treat this question as one of the questions where you have to visualize 3D in your mind. Then only you can solve these questions. And if you solve this question, trust me, you have a clear understanding of 3D visualization here. 10-meter long horizontal wire extends from northeast to southwest. It is falling with a speed of 5 meters per second at right angles to the horizontal component of the Earth's magnetic field of 0.3 into 10 to the power 4 Weber per meter square. The value of the induced EMF in the wire is. Now, I will explain this question in detail here. I don't expect that you will definitely get the answer for this question. So please see the solution for this question. It's a very good question. Not difficult, but you will see this. You'll realize after seeing the solution, it's actually easy. So let's say you can draw a table here, or you can draw any reference. Okay, so 1.1 10 to the power minus 3. Okay. Okay, no issues. Let me explain this question because it's a very good question. So let me explain this because I'm not asking also the solution for this question because I will only explain this in detail to all of you. Please here. Let's say take a table here. You can take any what you call reference. You have to just visualize. So to make you visualize, I'm writing these diagrams here. Take a table here. This side will not be visible to you. This is visible to you. This is visible to you. This is also visible to you. This is a table. You have a table here. So I have taken table. I have taken a table. Now, over this table, I will write all the directions here. This is your north. This is your south. This is your east. This is your west. Like this, you can write. This is a 3D visualization, right? So, this is the top of the table. Up is your top of the table. This is vertical. You can say vertical. This is a down. Okay. Vertical direction. This is horizontally. We have placed the table. So this is a horizontal plane. You can see this is a horizontal plane. You can think that the table face, the table surface. What you have here, table surface is a horizontal plane. Is a horizontal plane. Okay. So one more thing here, I'll just remind you. On this Sunday in maths, I'm discussing right now calculus. But what I have decided now, 1 week, every month, 1 week, I'll devote for what you call algebra topics of class 11, so that I can complete that this like in 3-4 months, the entire algebra topics what we have in. So this Sunday, I'll taking binomial and binomial plus sequence and series. Both I will try to complete binomial plus sequence and series. This is what I will targeting for this Sunday. Every month I have to target 2 chapters like this. Then only I can complete the syllabus on time. Because in case if they take the JEE in February or January, we have very less time. So we have to go with a strategy. So the strategy is very simple. And now from now onwards, I'll take few classes of class 11 maths also. I'll take algebra also. So this Sunday, I will be taking what you call concepts and numericals of binomial and sequence series. So do revise the concepts studied in NCERT. Again, I'll repeat here. I will not cross any level of concepts beyond NCERT. I'm telling this here. Only the way you think will differ, but the conceptually, I will not take anything apart from what is given in NCERT. Normally, what you call idiots, I call them idiots only. They say that NCERT nothing is given, everything is given. The only thing is that you have to just understand how to apply it. What we are doing here, we're just understanding the application. That's it. So please revise it, all the concepts of these 2 chapters for the Sunday. Okay, now let's solve this question. So this is what we have. Now, what is given the question? Your rod is like this. Northeast, southwest. This is what you have. So rod is like this. The rod is kept like this. This is the rod. So rod is also on the horizontal plane. Then it's falling. Means what? It's coming down. The rod is coming down with a velocity of what? With a velocity of 5 meters per second. So till now you can see that 2 things are. See, you need what? You need VBL, na? VBL. So you got the value of you got L thing. L value is what? 10. This is 10 meter for the question. This is given as 10 meter in the question. This you got. Second, you got V also. What is V? V is your 5 meter per second, and they are perpendicular also. So these 2 conditions are satisfied till now. Okay. Now about magnetic field. Now what is given to you as magnetic field? Magnetic field is given as what is horizontal component of the Earth's magnetic field is this Tesla. Now, this is what you should understand. Horizontal component means what? It is lying on the horizontal plane, which is the table of the which is the surface of the table itself. And always remember that whenever you are given with horizontal component of Earth's magnetic field, I'll teach you in magnetic properties of matter again, Earth's magnetism. It is always in this direction, in the north direction. This is given as how much? This is given as 0.3 into 10 to the power of minus 4 Weber per meter square. This is what is given to you. That's correct by the unit for magnetic field. Why? What is flux? Magnetic field into A. So what is magnetic field? It is Weber. It is what? Meter square. So we can always write magnetic field as what? Magnetic field as Weber upon meter. So there's nothing wrong in that. Or you can write Tesla also. So you can see that dimension of this and Tesla both are same. Right? So we got this. So right now you can see that magnetic field is not magnetic field is perpendicular to V. This is correct. But magnetic field is perpendicular to L. This is wrong. You can see from that. The magnetic field is not perpendicular to B. Right? Only a component of B will be perpendicular. What is this angle by this? This angle is 45 degree as per the question. This angle will be 45 degree. So how much you have to take here? We have to take here sine 40 because L is there na. We'll take what? We'll take B sine 45. B sine 45 degree will be perpendicular. This will be perpendicular to L. So what is the answer? Answer will be your V L into B sine 45. Now these three will be mutually perpendicular. So answer will be what? Write the value of V now. What is V here? 5. What is length? Length is 10. What is B here? B कितना दिया हुआ है देखो 0.3 into 10 to the power of minus 4. Sine 45 is what? Sine 45 1 by root 2. 1 by root 2 is what? 0.707. You know it very well, right? This is what we have. So we'll remove this 10 to the power minus 3 we have to make now. So this basically, by the way, what is this? All the answers are given in scientific notation here. You can see here. All of our scientific notation answers. So now we can solve it. We can multiply 7. So 7 into 5 will get approximately into what? 3 by 10. 3 by 10 will get here into what? 10 to the power, let's say minus 3 by 10. 10 more. This will get. So now we have to solve this. So how much you will get now? This is your 7 into 3 is 35. 35 into 5 will do. So we'll get here. So like this 10. So 100 has 1.05. We'll get 1.05. 1.05 into 10 to the power minus 3. If you round off at this point, what? It will remove this, right? So you can increment and you can write 1. Approximately 1.1 you will get the answer for the question. This is what you have. A very good question here. You can see the level is not difficult, but this question gives a clear picture of what is the actual meaning of motional EMF. If you want, you can ask a doubt. Otherwise, you can take the screenshot here.
Sir,
Bolo.
so can you explain it again, please?
Okay, please. See, the question is a 10-meter long horizontal wire extends from northeast to southwest direction. It is falling with a speed of 5 meters per second at at right angles to the horizontal component of the Earth's magnetic field, and the value is given to it. The value of induced EMF in wire is. So first of all, we have to visualize the diagram here. See, to make you visualize this diagram, I'm taking the reference of a table here. This table. So this face of the table, you can think as what? Horizontal plane. On this plane, I'm drawing north, south, east, west like this. The rod is along this direction, northeast and southwest direction. This is the direction of the rod, and the rod is falling down. So 5 meters per second. So right now, what you can see, L is given to you, V is given to you, and both are mutually perpendicular. This information is given to you. ये समझ में आ रहा है अभी?
हाँ, sir.
Now next, what they have given you, they have given the horizontal component of the Earth's magnetic field as what? 0.3 into 10 to the power minus 4 Weber per meter square. Now, horizontal component of the Earth's magnetic field will always be in this direction, from south to north. This comes from Earth's magnetic field chapter. Whenever they talk about horizontal components of Earth's magnetic field, obviously it will lie on the horizontal plane, means this plane itself. Okay, and then that goes from where to where? South to north. As in. So you can see that right now this magnetic field is perpendicular to V. Because this is lying on this plane, no? So this magnetic field is perpendicular to V. That's okay. But this B is not perpendicular to L. ये समझ में आ रहा है आपको? B and L are not mutually perpendicular. ये समझ में आ रहा है?
Yes, sir.
Now you can see a component of B. B तो ऐसे है ना, B is like this. If I take the component of this, I'll get two components. One component is what? Cos this side, B cos theta, I'll get this side. And B sin theta this side. So B sin theta will be perpendicular to L. No? Now this, your length and V are mutually perpendicular. So this you will get the EMF by multiplying these three. Is it clear now?
Yes, sir, got it.
Okay, so done. You can take the screenshot here. It's a good question. Not difficult, but very good question. You can clear the concepts of most EMF. Take the screenshot if you have taken. It's okay. Otherwise, I'll remove now this. Okay, done. Please say now. Next. Okay, so I have revised two concepts till now. That is your Faraday's law and the motional EMF, right? Now, let's see the next. A very good question here. Now, I'm trying to revise self-induction and mutual induction with all of you. And at the end, I will be revising this is what you call AC dynamo. This is how I'm revising the entire concept. Okay, so let's solve this question. Please solve this. Now I'm revising self-induction, mutual induction, and then AC dynamo. This covers all the things that you have in your syllabus here in this unit. If anyone is getting the answer for this question, you can let me know here. Easy question. Again, I'll repeat here. Do solve all these sheets. I'm going through all the questions and I'm picking only those questions which are relevant to your NCR textbook. And if you complete these sheets, all your concepts will get revised very fast here. The best part, you will get the recorded video after the class. You can always save it in some folder and you can write what you call quick revision of physics. NCRT level. With a smiley face, you can keep it in a folder and you can keep revising from this video. Again and again. Only 1.5 hours. That's it, 1.5 hours. You can just go through the videos fast and you can revise it. Anyone giving the answer for this question here? कोई आंसर बताओ इसका? It's easy question. आराम से take your time, not an issue है. आप solve करो इसको. Okay, चलो. I feel like you have not revised or like you are not clear with the concept self induction. तो मैं जल्दी से review करता हूँ self induction का concept क्या होता है, okay? And then we'll solve the question. Please hear. चलो. Not reply now anyone. Just I'm just explaining the concept now. Please hear. तो क्या होता है? कैसे होता है? See here. What you have studied is what this. आपने क्या study करा है? You have seen the case of solenoid like this. You have solenoid here. You have solenoid, right? And for this, we have derived the formula for self-inductance, that is L. Right now, it's vacuum. You have derived with for vacuum. If you remember, we have derived for vacuum. The medium inside the air, you have air inside this vacuum. And what is the formula we have got here? Mu naught times of N. N is the number of turns per unit length into what area? Area is what pi r square. Pi r square into the length. Right? This is the formula that we have got. Or N square, sorry, N square. This is the formula of self-inductance that we have derived for solenoid. If I am going wrong somewhere, please correct me here. Okay. So now, if what is this is a specific formula. This formula, what you see here, is a specific formula. Why specific? Because it is valid only when these areas are circular turns like this. Okay. What is general formula? If I ask you what is general formula for self-inductance? General formula for self-inductance will be L equals to mu naught into mu R. What is mu R here? Mu R, if let's say if you keep some other material inside in this gap. So mu R is the relative permeability of that medium, what you're keeping inside this. If you keep some ferromatic substance like you did in class 10, right? So you have to write the mu R from there into what? Into n square only you will have here. Now you will not write it circle, no? It can be rectangle, it can be triangular shape also, this cross-sectional area. So we write only area into what? L. Now you should not get confused. This L is the length. Okay, so I'll just replace with small L so that you will not get confused. A second. I will write this small L here. Small L. This is small L. Total length is L here. Okay, this is what you have. So this is the general formula. Now this area can be what? This area can be like here you have circle, na? You can have triangles kept like this, triangle like this, and you can give the winding over it. Okay, you can have rectangles like this, and you can keep the winding over it. This is the mean. Here you have circle, again circle, again circle. But you can be anything, any shape. It need not be a circle. For circle only you are writing pi r square. This is for circle. So by the way, what is phi? Phi is your Li here, and the EMF that you get is what? E equals to minus of L di by dt. This formula you already know here. You should not miss out. And the energy stored formula is what? Half Li square. So I have written down all the formulas for a self-induction case. If you want, you can take the screenshot here. Now we'll solve the question. Okay, these formulas should always revise as far as the topic self-induction is concerned. ठीक है? इसको अच्छे से notes बनाना, ऐसे revise करना इस sheet को. I'm requesting all of you. It'll help you like anything. Okay, now let's see here. How will solve this question? First of all, this question is not having a clear data. I'll tell you what's the meaning of not having a clear data here. What is given to you? A copper wire is wound over a wooden frame whose shape is that of an equilateral triangle. Okay, now instead of circle, they have told you that you are using what? Triangle. You have kept triangles like this. You have kept triangles. All are triangles like this. You're keeping triangles here, okay, and you are forming. So the winding goes over a triangle, not a circle here. This is what is given to you in the question. Instead of circle, now you have a triangle here. This is what is given in the question. There is equilateral triangle. And the linear dimension of each frame is, okay. So obviously you will have AA, so area of each face. Now this area, what you see here, this area is what? Area is root under 3 by 4a square. No? So area will be replaced by this formula. Okay, done. This is what you have in the beginning. Initially, you can say. Initially, it is like this. Now, finally, what they're telling you now if the linear dimension of each side of the frame. Okay, so you have a length also here, by the way, L. Now, what they're telling you. Okay, this is easy question. Sorry, there's no confusion in this question. Now, finally, what they're telling you? Finally, they're telling you that now you increase each side of the frame by a factor of 3. So what will happen to area? Area will become 9 times. So now finally we'll see that your area A prime will become what? Will become, because you replace A with 3, so it will become 9 times of A. Now the new area is what? 9 times of A. Keeping the number of turns same. If the linear dimension of each side of the frame. So not only this, even the L goes to what? 3L. Now the new L is 3L. So what is the new mutual L? So they're asking you the self-inductance of the coil is what? Okay. So if I ask you L prime by L, what is L prime now? If you use this formula, you write here mu naught into mu r. Let's say now number of turns remains same, n square. Area becomes what? 9 times of initial area, and the length becomes 3 times of L. By what? By you will write mu naught into mu r into n square into just area A into length. What will happen? You can see what all things will cancel from here. So this will cancel, this will cancel, this will cancel, A will cancel, A will cancel, you will get 27. So what will happen? Now L prime is 27 times of L. It will increase by a factor of 27. This is the answer for the question. That's it. A good question, yeah. Not difficult, a very good question. You have to understand every date, every point in the question, then you can solve it very easily. Yeah. You can see. I can't say that's a question like this very, very difficult. It's the exact question. It's a question based on the formula of L. That's it. The only thing you should just keep in mind that this conversions, yeah, this is only for circle. No? It's like some other area of question that they have to replace with A. If some other medium you have here, MU, or that's it. Question is over. In this case, this is given to be equilateral triangle. So area will be what? Roots under 3 by 4 A square. And the length is L. So now they're telling you each linear factor is increased by a factor of 3. So what will happen? Even the sides of the equilateral triangle will increase by a factor of 3. So A will become 9A square. So 9, the area will become 9 times of A. Even the length will become 3L. And then put these values here. So you can see the numerator, you will get a factor of 27. So 27 increased by a factor of 27. If you want, you can take the screenshot. If anyone is having doubt in this question, you can ask me. I will repeat. Let's take the screenshot. Okay, let's the next question now.
So can you repeat?
क्या समझ में आया पहले ये बताओ इसमें क्या समझ में नहीं आया रिपीट में मतलब क्या समझ में नहीं आया
अंडर रूट 3L
अंडर रूट
3L
3L समझ में नहीं आ रहा है पहले लेंथ मान लो जो लेंथ दिया हुआ सोलनॉइड का वो पहले L है तो दिस गिवन ना सी इज गिवन द क्वेश्चन दैट द लीनियर डायमेंशन ऑफ ईच साइड ऑफ द फ्रेम मींस व्हाट this length is L now it is increased by 3L it's given the question see is increased by a factor of 3 जितने भी linear dimension how many linear dimensions you will have here one is your side of the equilateral triangle that is also increased and initially you have taken A here A becomes 3A so what will happen 3A means what 9A square so the factor the new area will be what 9A and even the length of the solenoid which you had L now it will become 3L so length is 3L so now in this formula I have to change L with what 3L area with 9 so I'll get 27 now. It's written here if each linear dimension if linear dimension of each side of the frame so ये length is also one side of the frame ना और एक तो side ही होता है so all the linear dimensions we have only two linear dimensions one is length of the solenoid here and second is what the triangular what you call edges length A all are increasing by a factor of 3 so what will happen your area will become 9A area of each turn there will become 9A this will become 3A so 27 is the factor this is my review
yes sir
देखो यहाँ क्या है ना अभी देखो ऐसे पहले सोलनॉइड सिर्फ सर्कल था you are placing circle like this now you're not placing circle you are placing triangle like this in the solenoid ये अंतर है दोनों में ठीक है they have given a in the beginning so the area was root 3 by 4 A square now that's increasing all the side with a factor by a factor of 3 so each side will become what 3A so the new area will become 9A and the length also let's say initially length was L now it will become 3L so write these values here L will become 3L area will become 9A so 9 to 3 27 is the factor by which the L will increase this is the answer for the question आपको विजुअलाइज करना पड़ेगा इसमें कुछ भी नहीं है you're replacing circular what you call areas with equilateral triangle area so now so the formula will be what just A here and L A is what root under 3 by 4 A square now in the question they're telling you now increase each side by a factor of 3 and then the length by 3 so increase there L will become 3L and area we can see 9 so 9 to 3 29 by 27 factor it will increase okay let's see the next question here. Yeah, please solve this question a easy question please solve it the self-induced EMF of a coil is 25 volts when the current is changed at uniform rate from 10 ampere to 25 ampere in 1 second. The change in energy of the inductance is energy is what you need the value of L is not given to you. L is not given to you, but we can use this formula. Why? Because EMF is given to you. Know what is the EMF here? 25. So you'll let 25 equals to what? L. I'm just writing the value here. Is 10 to 25. So what is DI? DI is given as what? I'm just writing the magnitude here at this moment. So you'll get 15. Change what? 25 minus 10. You can take this value and 1 second. So from here we'll get the value of L. What is L here? 25 by 15. So we'll get 5 by 3. So 5 by 3 Henry. You got this? So what is change in energy? Change in energy, you can use the formula half times of L. L is what? 5 by 3 you can write here. Into what? I square, no? So I square means what? Initially, whatever the final minus initial. So final current minus initial current you do now. That's it. So we'll get half into 5 by 3. What is final current? 25 square. 25 square 625. Minus of initial current 100. So now you just solve this question. So now just solve this data. 5 by 3 into you will get what? You will get here 525. So it is divisible by 3, I guess. Yes, 5 plus 2 divisible. So 5, 3, 3 1 are 3, and then 22. So 7 and 5, 175 will get here. So 175 into 5. 2.5 also you can do if you want. Okay, I can multiply. So 5 is 25, 35 is 37, that's 7, 3 carry. So 5 plus 3, 8 by 2. So you'll get here 437.5, right? Joules. A very, very easy question here. You have to switch from here to here. That's it. First of all, with the help of this, calculate L and then use the formula. You will get the answer for the question. If you want, you can take this. You can take the screenshot. It's a very easy question. You can see it's a very, very easy question. This is in joules. जल्दी ले लो यार इसका स्क्रीनशॉट लेना है तो फिर Yeah. Again, a very, very easy question. You can see when a current in a coil changes from 5 to 2 in N, the average voltage 50 self-inductance. Again, a very, very easy question here. They're asking you to calculate the value of L. So what is given to you here? Voltage is given to you. This formula again you can use 50. L you have to calculate. It goes from where to 5 to 2. So I'll change it. I'll take the change. 5 minus of 2 you have here. Answer 0.1 second. That's it. No. So we'll get from here. You cross multiply 50 into 0.1 means what? 1 by 10 into what? We'll add 1 by 3 Henry. Henry is the L value. That's it. So we'll get for 5 by 3. What is 5 by 3? 5 by 3 will be your. आंसर नहीं दिया हुआ है. कुछ गलत किया क्या मैंने? 5 by 6 0.67. हाँ तो है. This is what you get. Okay, 1.67 Henry is the L value. A very, very easy question. You can see here, right? जैसा पिछला था same question यहाँ पे. Difficult है. This is a straight question. You have to just use whenever EMF is given to you. Use this formula. That's it. Equals to minus of. I'm removing minus because I'm just looking for the value of L. Change in current by change in time. So I will get the answer for the question. As simple as this, right? Easy question. Let's see the next question now. Yeah, please solve this question. Again, a very easy question. Please solve it. जल्दी दो उसका आंसर. आसान क्वेश्चन नहीं, it's easy question. The total number of turns on cross-sectional area in a solenoid is fixed. However, its length L is varied and as a separation between the windings. The inductance of the coil will be proportional to. कोई आंसर आ रहा है यहाँ पे? Fourth option. Okay, Anjali is giving fourth option. 1 by. Okay, it's a very, very easy question. You all can solve it. देखो क्या question है? Please see. Again, it's a question based on what? Straight away, it's a question based on L formula. What is the L formula you have? L formula. You can use mu naught into mu r. Otherwise, you can just use this mu r is not required by the way. Okay, that's okay. Area into what? Length. This is the formula. Okay, I'm just using a small L here because it should not get confused. All the options will be in a small L in that case. It's length, na? Because L we are using for inductance, mutual inductance at this moment. So self-inductance at this moment. So what they're telling you here, the total number, okay. the total number of turns. This n is constant. This n is what? This part is constant. This part is constant. However, its length is varied by adjusting the separation between the windings. Okay. The inductance of the solenoid will be proportional to what? Okay. So now see, a total number of turns is constant. What is small n here? Small n is total number of turns per unit length. Na? So what will get? You will this formula of L will convert to what? Mu naught times of mu r into what? N square by L square into what? A into L. L will cancel. So what will get here? Mu naught into mu r you will get into N square into A by L you will get. You can see that the only see what you're doing here, you are just changing separation here, so length will change. But area of cross section will remain same, n will remain same. The only factor that affects is what? Length, and is what? Inversely proportional. So the answer is what? Fourth option. Question is over. A very, very easy question based on simple application of the formula here. You can see it. Here you are just changing the length. How you can change that? If you just bring the solenoid close, your L will decrease. If you bring the solenoid away, what will happen? L will increase. Right? But your area of cross section total number of turns will remain same, and hence the formula of L will get modified like this. The only variable you have L, that is coming in denominator, and therefore the option is 4. 4 is the correct option for the question. Okay, let's solve this question. Now we are entering into questions of what? Mutual inductance. This question, and this question. These three are based on what? Mutual inductance. These three questions. Okay, and these are very, very easy. So let's see if we can solve it here. You know the concept of mutual inductance. I will quickly review for all of you. You will have two coils in this case. You will have two coils here. One coil and second coil, let's say. This is your coil number 1. This is coil number 2. You pass current through one of the coils and see the flux change on the other coil, like this. So the flux linked here is proportional to what? Magnetic field. That magnetic field depends upon I. So phi equals to I. I is in the second. Okay. So phi equals to what? Mi you write here. Mi. And then what is the EMF induced? Minus of M di by dt. This is the concept that we have seen here on mutual inductance. Solve it. Again, a very, very easy question. Please solve it. This question is given in NCERT textbook also here. Is here. This question is given here. See. This particular question. You can take a screenshot after the class. You can always see this question as well. A very, very famous question. You want to take the screenshot for this question, 6.9. After the class, you can always have a look over it. Okay. Okay, let's solve this question. See what is given to you in the question here. The question is, a small circular loop of wire of radius A is located at the center of a much larger, means what? B is given very, very greater than A. And the exactly same information is given textbook also. See, R2 is very same thing. Hope you understand the benefit of like studying what you call NCERT textbook. That too with clear understanding. So a small circular loop of wire. Okay, this is what you have. The two loops are in same plane. Means what? You have a small loop here. Radius is A. And then you have a big loop here. Both are in the same plane. This is given to B. So what will happen for this? For with reference to, I will say this is your loop 1, loop 2. with respect to loop 2. Loop 2. Loop 1 is just a point. Loop 1 is just a point. This is very, very important. Just a point. Why? Was given no. Since your B is very, very greater than A. This is very, very important. Now you are passing a current through this. What is the current value? I equals to I naught cos of omega t. Definitely create a magnetic field here. It will go into the out, into or out, because it keeps changing direction. No? So whether into or out. Basically perpendicular to this. If the current varies, obviously the flux will also change, right? So you will get an EMF induced here with this formula. They're asking EMF induced. Use this formula. You can use this formula, right? The EMF induced in the smaller loop will be equal to what? So for EMF, what do you want? Basically, you want EMF induced equals to what? Minus of d phi by dt. You can leave minus right now. D phi by dt you can use here. D phi by dt. EMF induced is d phi by dt. So what is d phi here? You can see what is phi here? B into A. B into A. B into A by dt. So if you want, you can keep this minus also. So minus of area will come outside. What is area by the way? Area is your pi a square. Pi a square. This is the area. And what is B? Mu naught times of I by, what is the magnetic field formula at the center of the loop? Mu naught times of I by 2 times of R. This is what you know. What is R right now? R is B. So mu naught into 2R will come outside. So you will let mu naught out. You will let 2 times of R. R is what? B. Into what? D of magnetic field. What is magnetic field given to you in the question? Cos omega t. D of cos omega t by dt. That's it. This is what will happen. This will give what? This will give you minus sine omega t into omega. So what is the answer you will get? You will get mu naught times of pi into a square by 2b into will get sine of omega t multiplied by omega. This is available in option number A. This is the answer of the question. A very, very simple question here. You can see that why you will have an EMF induced here, because you have a loop here in which you are changing the current. So obviously the flux will change here. And what is the EMF induced? E equals minus d phi by t. You can use this formula. What is the magnetic field formula? B into A. Either it will be cos 0 degree or cos 180. But this is what you will take, and then you can solve it. If you want, you can take the screenshot of this question. Similar question is given in NCERT. After the class, definitely you can see from there. Easy question. Okay, let's see the next question now. Again, a very, very easy question. Please give the answer for this question fast. This way anyone can answer. Yeah, it is that easy. It's a बहुत आसान question. How many questions are remaining? 1, 2. That's it. 2 after this 2. Please solve it. I'm going slightly fast. The reason is I have to stop this class and I have to again start at 9 o'clock. Today and tomorrow I have planned only teach you theory in detail here of relative velocity, all those concepts. Yeah. So for that I need a small break also. So for that reason I'm going fast. Please give me the answer for this question. This can be solved by each one of you. Are what they are telling you? Two long coaxial of the same length, the inner and the outer. कोई आंसर दे रहा है? Okay, 4. चलो देखते हैं. Okay, please here. Okay, Anjali is also giving 4. Okay, please here. क्या दिया हुआ इधर? See here. Two long coaxial solenoids of same length है. दोनों का length same दिया हुआ है. ठीक है. The inner and the outer have radii R1 and R2. ठीक है. Answer is the ratio of the mutual inductance and self inductance of the inner coils. Okay, inner coil के लिए बात कर रहा है. Ratio of what? Mutual inductance by self inductance. यार self inductance अभी पढ़ा आप लोगों ने. क्या होता है? Mu naught, let's say vacuum is there. Okay, mu naught times of what will let here? You will let here n1 square. N1 square into what? Pi into R1 square into what? Into length. This is the formula. And here what let you let here mu naught times of n1 into n2 into inner only. You know, you study the formula n2 else. What will happen? Everything will get cancelled. You will get everything will cancel. You will get only n2 by n1. It's that easier. Question is over. If you want, you can take the screenshot here. It's a very, very simple question. You can see You just revise. If you remember mutual inductance area, we write always the area of the inner solenoid. Okay. Okay, so we have revised now self-induction and mutual induction also. Now we will revise the last topic, that is your AC dynamo, with the help of two questions. As I promised all of you, I will not cross the level of NCRT. I have not crossed for any question NCRT level here. And you can see from here how the questions are framed. Neat questions, you will laugh. You will literally laugh at the questions. If I start taking the neat questions, I'll show you that also one day. In one day only, I'll cover like all the book one in 3 hours. I will take one slot, what you call 3-hour class. I'll cover all the questions, all the concepts related to neat questions. You literally laugh at the papers there. Solve this question, a very, very easy question. Oral question, give me the answer fast. Oral question, oral. This I have discussed in theory with all of you. A coil of cross-section area capital A having a small n turns is placed in a uniform field B. When it is rotated with an angular velocity omega, the maximum EMF induced in the coil will be. What is the answer? अरे यार इसमें इतना समय लग रहा है, जल्दी बोलो इसका आंसर. I can't believe you're taking this much time for this question. अरे इतना टाइम क्यों लग रहा है यार? सिंपल से एसी डायनामो का ही क्वेश्चन है यार. सी एन बी ऑप्शन 3 यस 3 इसमें क्या था यार? तो मैं थ्योरी में पढ़ा था तुम लोग यार. E equals to what you get n b a omega sin omega t. This is called your E naught. E naught value is what? n b a omega. ये तुम्हारा पूछा है. Over. What do you want in this question? If you want to take the screenshot है fast. इतना आसान होता है यार, इसमें भी ऐसे करो तुम लोग. लास्ट क्वेश्चन, एटलीस्ट ये तो कंप्लीट कर लो. अरे भाई बता इसका आंसर. सबको पीटूंगा यार इंस्टीट्यूट खुलने से भी. क्या मजाक कर रहे हो यार? ये जे लिखा हुआ क्या? इसको हटा देता हूँ मेरे को एक मिनट. इसको मैं भी ऐसे हटा देता हूँ. अब आंसर कर दो. ओके, अंजलि का आंसर आ रहा है. 4 आंसर करे हो? अच्छा 4 हो सकता है. हाँ 4 हो सकता है. अरे भाई देख, जैसा देख अभी आपने थप्पड़ मार सब क्लास के बाद. सी है अभी देखा. ई इक्वल्स टू व्हाट? ई नॉट साइन ओमेगा टी. ये होता है फॉर्मूला. तो ठीक है ना. साइन कर्व कैसा होता है? साइन कर्व ऐसा होता है ना यार. दिस इज वन टाइम पीरियड टी. दिस इज वन टाइम पीरियड टी. टी इज गिवन इन द क्वेश्चन एज व्हाट? 10 seconds. This is what? This is your t by 4. This is what? T by 2. What they asking? This is maximum. This is what? Minimum. Right? So maximum for the first time they're telling you ना. Maximum and minimum respectively. Maximum कब होगा? T by 4 पे. तो 10 by 4 ये डिवीजन सबको आता है. 10 by 2 5 होता है. 5 तो कहीं है ही नहीं. इसी से आंसर आ गया भाई. T by 4 is what? 2.5 seconds. क्या चाहिए इसमें यार? क्या रो रहे हो? चलो यार डन. Please improve. Please improve. I'm requesting all of you यार. There's nothing in this question. एक normal sine graph है यार. Normal sine graph. EMF induced, right? You can see from here. 0 starts from 0. Maximum is T by 4. Again minimum T by 2. Question is over. That's it. T is given 10 seconds. What do you want in this question? Take the screenshot. Question now. I stop the class. Okay, chalo. Done. Okay, class is over.